Good day, good people. This video is on Chapter 9, Hypothesis Testing. Specifically, we're going to go over how to use GeoGebra and your TI83, 84 calculator when trying to do these hypothesis tests for specifically the T and the Z proportion testing. So let's jump right into it. According to an article in Bloomberg Business Week, New York City's most recent adult smoking rate is 14%. Suppose that a survey is conducted to determine this year's rate. 9 out of 70 randomly chosen New York City residents replied that they smoke. Perform the hypothesis test to determine if, the rate is still 14% or if it has decreased, and compute the p-value. Based on your p-value, what is the conclusion if we test at a significance level of 5% or rather 0.05? So, obviously, we're given a little bit of different information here. So, key indications is if you're just getting a lot of percentages, and then most specifically, if you are given things like 9 out of 10, 2 out of 5, this may mean that we're going to do something with a proportion z-test. All right. So let's write down what we know. We do definitely know that since it says 9 out of 70 randomly chosen New York City residents, so that means that my sample size is going to be 70. Then, if it's 9 out of 70, that means my number of individuals of this sample is going to be 9. So my X is going to be 9. That means my sample proportion, or my p hat here, right, would be X divided by N, which will be 9 out of that 70. If we plug it into our calculator, that gives us approximately, turn her on, 0.128. Okay, now that's the first piece of information we know. And then another piece of information we know is that our population proportion, and then we're talking about the population of the New York City, is at 14%. So we could say P naught, or P, would equal to 14%. However, we don't deal with percentages as a percent, we deal with it as a decimal, so that'd be 0.14. Now, our next step would be to figure out what is our null and our alternate hypothesis. So looking at this, if I go back and read through it, right, it says perform a hypothesis test to determine if the rate is still, and remember, keyword is still 14%, or if it has decreased. So if it is still, that means that's going to be our null hypothesis, meaning that our p-value, all right, not our p-value, our proportion is still going to be 0.14, all right? Or if it has decreased, that means our alternate hypothesis should be that our p is going to be less than 0.14%, right? So based upon this, we know that this is going to be a one-tailed test, right? And we also know it's a one-tailed test because we're dealing with the left-hand side, or we're dealing with the proportion that says less, right? So we are only dealing with the left-hand side. So let's jump right on into our GeoGebra of how we should insert this in. So if I come to GeoGebra Classic, I am going to select probability. From selecting probability, I want to deal with the statistics. In statistics, we have the z-test for a mean, we have the t-test, but since we know that these are proportions, we're going to do the z-test of a proportion. Now, what is our p-value? Our proportion, our population proportion, right? Our population proportion is 0.14, right? And our alternate hypothesis, if we recall, is less than. Then what is our number of successes? So the sample number of successes is pretty much our X value, right? The number of individuals in this sample. So that would be 9. And our sample size was going at 70 individuals. And so now we can see all of our information. Okay, so based upon this, we can now say that our z-score, or our t-test, right? Not our t-test, our test statistic would be a negative 0.2756, and our p-value would be 0.3914. So our test statistic, all right, was a negative 0.27556, right? And our p-value was a 0.3914. Now, when we are doing our hypothesis testing, we base our conclusion upon our p-value. So, is our p-value greater than or less than our significant level at 0.05? Well, that's easy. 0.3914 is greater than 0.05. So that means we what? We do not reject our null hypothesis, and that means we do not have enough information or have enough evidence to support our information. Okay? All right. So, our next question, it says registered. Oh, I did forget. Mm, mm, mm. If you are using your TI83 calculator, right? Let's plug all of this in just in case you have a TI83 and you don't want to use your GeoGebra. So you come here to stats, you scroll over to tests, you want to do a proportion, but you only have one proportion. So it'll be a one proportion z-test. You click enter. Now you put in your P naught value, which is our population proportion, which would be 0.14, right? If you have your X value, which will be in this case 9, and then our N value would be 70. And then you need to click over and decide which one was your alternate hypothesis. In this case, it would be less than, and then we want to calculate. And we get the same values that we did in GeoGebra. And again, since our p-value is greater than 0.05, we do not reject the null hypothesis, and that means we do not have enough evidence to prove our hypothesis test. Now, moving to our next question. It says registered nurses earn an average annual salary of $69,110. For that same year, a survey was conducted of 41 California registered nurses to determine if the annual salary is higher than $69,110 for California nurses. The sample average was 71,121, with a sample standard deviation of $7,489. Perform the hypothesis test and compute the p-value. Based on your p-value, what is the conclusion if we test at a significance level of 5%, or rather 0.05? So again, this is very similar to what we were doing before. We need to write down what information do we know, right? We know that our sample, well, not our sample, we know that our population of registered nurses, right, have an average of 69,110. So that means we have 69,110 is our population mean, right? But for that same year, 41 registered nurses. So 41 means that my sample size is going to be 41. So N equals to 41. And so what we do know is the sample average is 71,121. So if we're talking about that, that means our X bar is going to be 71,121. And then it says our sample standard deviation, which means S will equal to 7,489. Now, based upon me knowing all of this information, since I have only a sample standard deviation, not a population, but a sample standard deviation, that means we are going to do a t-test statistic, right? Remember, you do a t-test when you have this sample standard deviation and not the population standard deviation. So how must we plug in all of our information? Well, before we get to doing that, right, we may want to know what is our, what is our null and alternative hypothesis? So if we look at this, right, we know that our mean or our population mean is 69,110. But let's go back and read through so we can figure out what our alternative hypothesis is going to be. So it says for that same year, a survey was conducted of 41 California registered nurses to determine if the annual salary is higher than 69,000. So the higher indicates that we are going to use a greater than. All right. So that means we need to write greater than 69,110. Okay. So being that this is greater than, we will know that this is a right hand tail test, right? And then it is also still what? A one tail test. All right. So moving to, I'll do our calculator first, right? So if we want to do the stat test in our TI83 and 84, still will have the same thing. We come to stat, we go to test, oopsies, and we go to t-test. Okay. So now we put in what is our population mean, which will be 69,110. Then we put in what is our X bar, which will be 71,121. Then we put in what is our sample standard deviation, which will be 7,489. And then we put in what is our sample size. Our sample size is 41. Now, again, based upon what tail or what side you're dealing, if you're dealing with a not equal to, a less than, or a greater than, that is the one that you will select. Then scroll down and click calculate. So that gives us what our t-score, our test score of 1.7194 and our p-value of 0.466. Now, if you don't have a TI83 calculator, that is fine. That means we can still come here to GeoGebra, all right? And then we will, again, in our statistics tab, we can select a t-test of a mean. In the t-test of a mean, we are going to insert our information. So what is our population mean? That is 69,110. All right. Our alternate hypothesis is going to be greater than. Our mean of the sample is 71,121. Our sample standard deviation is 7,489. And again, our sample size is 41 people that were selected. As you can see, you still get the same answer for both of them, right? We see that our t-test here is set 1.7194 and we still see that our p-value is 0.00466. Okay, so based on this, what we need is that test. So this is our test, is the 1.7194, and our p-value is 0.0466. Now, again, if we are doing a hypothesis test, or since we are doing a hypothesis test, we want to compare that with our significance level. And this time it is going to be a 0.05. So is 0.0466 less than or greater than 0.05? It is less than. And since it is less than, we reject our null hypothesis, right? And therefore, we have significance evidence that nurses earn more than the average of $69,110. Okay? And that will be it for our video here. Let me know if you have any questions.